In this lesson, we will solve a system of linear inequalities. Now, just as we solved linear inequalities with one equation, the same rules apply when you have two equations or when you have a systems of linear inequalities. And that is, if you have less than or equal to, greater than or equal to, you're going to sketch a solid line. If you have less than or greater than, you're going to sketch a dashed line. Remember, you're always going to shade the true side, and you can use test point 0, 0 to test whether a side is true or not. You could also use a boundary method. The only difference is step 4, and that is the solution of a system of linear inequalities is an ordered pair that satisfies each inequalities in the system. In other words, it's the overlapping part, the part that you colored or shaded twice. Okay, so you would perform the whole process on your first line, okay, including the shading. Do that same process of line 2, including the shading. And then you want to look for the part where you shaded it twice. You shaded the first time with line 1, and you also shaded that region when you shaded the results from line 2. And then just that overlapping part is where your solution lies. So it makes more sense if we actually do an example. So let's go ahead and do an example. So here we're given two lines, and we're going to start one at a time. Since that line is given in standard form, I'm going to go ahead and use the x and y intercept, meaning let x be 0, then get your value for y, and then turn around and let y be 0 so that you can get your value for x. We call that using the x and y intercepts. So those are our x and y intercepts. Now we're going to take them to go ahead and plot our points and then sketch our line. So the first point is 0 and up 1. The other one is over 1 and stay at 0. And yes, we're going to go ahead and draw or sketch a solid line because notice you have less than or equal to for line 1. Now, before we move on to line 2, we want to determine for line 1 which region would we shade. Now, we can use our test point of 0, 0 and see if we're going to shade the region to the left of the line or the region to the right, or what we call the bottom region or the top region. So let's go ahead and plug in 0, 0 as our test point. Remove x, remove y, replace them both with a 0, and then let's read the statement. So what we have here then is 0 is less than 1. That is a true statement. So that means the side where the test point was here, notice that is your lower region. So you're going to go ahead and shade that region to the left because that is where the true region lies. Now we are not done with the equation. What we have to do now is we have to graph our second line. So let's go ahead and do that, line 2. So our second line, x equals 1, meaning you're going to sketch a, and notice it doesn't have a line underneath it, so it's a dashed line passing through the x-axis at 1. That's going to be a vertical line. And so now we have to decide, are we going to shade to the left of that vertical line, or are we going to shade to the right of that vertical line? Well, all we have to do is plug in our test point of 0, 0, because that's our test point there, which means that's the same thing as the left side, or the upper boundary of this line. When we do that, let's read the statement. 0 is greater than 1. That is a false statement. 0 is not bigger than 1, so that means that we are not going to shade the left of that vertical line because it's false. We have to shade to the right of our vertical line. And now that both lines have been shaded, we are looking for the part that was double shaded. Red and blue makes purple. So we're looking for that darker purple region, which is as follows. Okay, so even though you did several shading here in red and then you did some shading in blue, the solution is only the region that overlaps. That is your solution to both linear inequalities.